Fluid Mechanics 1 SEMM 2313. So in this slide, we will discuss about the modeling and similitude. Models are widely used in fluid mechanics. Major engineering projects involving structure, aircraft, ship, rivers, harbor, and so on frequently involve the use of models. A model is a representation of a physical system that may be used to predict the behavior of the system in some desired respect. And the physical system for which the predictions are to be made is called the prototype. Theory of models. The theory of model can be readily developed by using the principle of dimensional analysis. So we need to write this term, so we call it as a pi1 is equal to function of, so the f here is, we call it as function of. So we say it as a pi1 is function of pi2, pi3 until pi n. If above equation describe the behavior of a particular prototype, a similar relationship can be written for a model of this prototype. That is, pi1 for model is the function of pi2 model, pi3 model, and so on. Pi terms without a subscript will refer to the prototype. So this is the common rules, and the subscript m will be used to designate the model variable of pi terms. The pi terms can be developed so that pi1 contains the variable that is to be predicted from observation made on the model. Therefore, if the model is designed and operated under the following condition, so we could write as pi2 model is equal to pi2, so means this term is for model and this term is for the prototype, because the equation is the same, and then we could say that it must have some kind of similarity. So then, with the presumption that the form of f is the same for model and prototype, it follows that this one, pi1 model is equal to pi1. Equation 2 is the desired prediction equation and indicates that the measure value of pi1m obtained with the model will be equal to the corresponding pi1 for the prototype as long as the other pi terms are equal. The conditions specified by equation 1 here provide the model design condition, also called similarity requirements or modeling laws. So, and then when we do similarity and modeling, the one important parameter is about the model scale. We will take the ratio of the model value to the prototype value as the scale. Length scale are often specified. For example, as 1 to 10 or as a 1/10 scale model. The meaning of this specification is that the model is 1/10 the size of the prototype, and the tacit assumption is that all relevant lengths are scaled accordingly. So the model is geometrically similar to the prototype. So when we talk about the model scale, so it only refers to the geometry. Okay, so and then if we refer to another part, which is velocity and so on, we do not call it as a model scale. There are, however, other scales such as the velocity scale, the density scale, the viscosity scale actually sometimes used in similarity analysis. Models for which one or more similarity requirements are not satisfied are called distorted model. Models for which all similarity requirements are met are called true models. So what is this meaning? So if you do the similarity between your model and the prototype, sometimes your model need to be rebuilt because the reduction of size it actually will not give us a correct value for another parameter. That's we call as a distorted model. So means we need to enlarge our model to make sure that it can be used or it can produce a similarity between model and prototype.